Alright, what's up guys? So in this video we're going to do this curve sketching question, and this one's a little bit tough because of the lot of moving parts and the fact there's just, when you differentiate it, there's just things going everywhere. So let's have a go. So question A asks us to find the stationary point. So f of x is e to the 2x plus 1 x to the 4. So I know that I need to use the quotient rule, the product rule. So u is e to the 2x plus 1 and v is x to the 4. So u dash will be 2e 2x plus 1 and v dash will be 4x cubed, like so. Now f dash of x will be u dash v plus v dash u. Now u dash is 2e 2x plus 1, v is x to the power of 4, plus v dash is 4x cubed, and then u is e to the power of 2x plus 1, like that. Now the next step is I want to just factorize it to clean it up a little bit. So what's in both? Well, I can see a common factor of 2, so I'll just write that at the front. I've also got e to the 2x plus 1 in both, so let's just write e to the 2x plus 1. And then you've got x cubed, so x to the 4 here and x cubed, so the highest value will be x cubed. All right, now that's all going to be outside of x plus what looks like to be 2. I think that's it. So that will be your first derivative here. And I need to find the stationary points. Now stationary points is when f dash x equals 0. So that's what I'm solving for. 0 is equal to 2e 2x plus 1 x cubed x plus 2. Okay, now to solve this might look complicated, but it's actually pretty straightforward because we're kind of using it's kind of similar to when you factorize a quadratic, when you make it equal to 0 and you're trying to find x-intercepts. This has to equal 0, so therefore straight away I know that this is going to give me a x equals -2. And then over here, let's do these one by one. Like this will never be 0, okay, because you've got the exponential in the power. That can never be 0, but this can be 0. So here is also my other solution. So they're your two possible stationary points. Now let's just quickly find out what the coordinate is that goes with this function at the top. So quickly subbing it in, f of 0 is going to be, I'll just put this in the calculator, so 2 of 0 plus 1, and then 0 to the power of 4. Okay, well that's just going to be 0. Should have seen that. What's f of -2? So let's change that up. So -2 plus 1, and then -2 to the power of 4. So that's going to be 0.7966, let's call it. Okay, so I'm just going to clean this up and write this as a coordinate. So your possible stationary points are 0, 0, and -2, 0.7966. And the next step is we need to determine the nature. So we've got to find out whether it's a minimum, a maximum, or it could be a point of inflection. So we do that by drawing up a table. All right, so I've just whipped up a table here to determine the nature. And as you can see, I've got x and f dash of x. And all I need to do is I need to choose a number on either side of my stationary points, because this tells me, this bottom row tells me what's the gradient at that point. Now I've worked out that's obviously 0. So let's just say -3, -1, and 1. And what are the points here? So what I need to do is, I just need to substitute this number into f dash x. So for example, -3. Remember, f dash x was this. It was this, and I just need to substitute these numbers. So I'm just gonna pop these all in the calculator and then I'll see what I get. So 2 bracket e to the power of 2 of -3 plus 1 -3 cubed outside of -3 plus 2. And you should get 0.363. Now I'm just going to pop all the other numbers in the calculator so that you don't have to watch me do it. Okay, so I've done all the numbers in the calculator now and I've got my values. And what I want to do just below it is I want to just draw what the gradient looks like to represent it. So here you can see that's a positive number, so it's going to be a positive gradient. 0 is obviously flat. negative, flat, positive. And that tells me that this does that. So that's going to be a maximum, whereas this 0, 0 bottoms out. So this is going to be a minimum. So I can go back here and write what my values are. So this is a max and this is a min. So question A is done. All right, so part B asked me to find any points of inflections. That means we got to find f double dash x. So we need to differentiate this whole function here. Now, what I'm going to do is I'm going to break this up into my u here, and I'm going to break this up into my v there, and I'll see how I go, because I'm going to have to apply the product rule a couple times, as you can see. So u is equal to 2e 2x plus 1 x cubed, and v is equal to x plus 2. So u dash, now as you can see here, I've got another product rule that I need to apply because I've got this one here and then this one here. So let's just do a sidebar over here, maybe in a different color. So this here, u is 2e 2x plus 1 and v is equal to x cubed. U dash is going to be 4e 2x plus 1 and v dash is 3x squared, sorry. So u dash v plus v dash u is going to be 4e 2x plus 1 x cubed plus 3 times 2 is 6x squared e to the 2x plus 1. Like so. So that is my u dash v. Also, that's my u dash for the one above it. Okay, so I've just boxed that up so hopefully you can see it a bit clearer. And then back to here, and then back to this box. So v dash will be just 1. So now I've cleaned it up a bit. Let's just bring this all together. So f double dash x is going to be u dash v plus v dash u. So u dash v is all of that stuff. So 4e 2x plus 1 x cubed plus 6. Now I'm just going to be consistent here. See how I put the x at the back? Just so I'm consistent when I have to bring it all together. I'm just going to move this x squared to the back. And this is going to be times by x plus 2 because that is the v. And then I'm going to have plus v dash, which is 1 outside of 2e 2x plus 1 x cubed, like so. Now I need to expand this first bracket out. Okay, so it's going to be this, 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 this. So I'm going to have 4e 2x plus 1 x to the 4 plus 8e 2x plus 1 x cubed plus 6e to the 2x plus 1 x cubed plus 12e to the 2x plus 1 x squared plus 2e 2x plus 1 x cubed. Okay, so now I know it looks super ugly, but let's just try and find any like terms. So what's the first one we got? We got 4e to the power of 2x plus 1 x to the 4. So are there any other x to the 4 terms? No, it doesn't look like it. What about the next one? We've got 8e to the 2x plus 1 x cubed. Okay, so I've got an x cubed term here. I've got an x cubed term there. And I've also got an e to the 2x plus 1, so they must be like terms. And then back here, I've got another x cubed. So bringing those ones together, let's just leave this at the front first. 2x plus 1 x to the 4 plus, okay, so 8 plus 4 is 14 plus 2 is 16 e to the 2x plus 1 x cubed. And then we're going to have left over 12e 2x plus 1 x squared. Is there anything we can simplify or factorize? I think we can factorize a 4e to the 2x plus 1 and an x squared. Okay, and then the first bit in the bracket is going to be x squared plus 4x plus 3. All right, perfect. So that looks like a quadratic right there. So that is our f double dash x. All right, cool. Now we've got to find any points of inflection. So we're trying to solve for f double dash x equals 0. So once again, you're going to consider this thing separately and then this bit inside. We'll be able to factorize what's in the square bracket. So that should be x plus 3, x plus 1. And then when does x equal 0? Well, straight away, I know x equals 0 at negative 3, x equals 0 at negative 1. Remember, e to the x is never going to be 0. So this one is going to be x to the 0. Okay, so now you've got 3 possible points of inflection, 0, minus 3, and minus 1. And what you want to do is you basically want to find what's f of 0? That's a coordinate. What's f of minus 3? That's also the coordinate. And what's f of negative 1? So you put that back into the original equation. Now I'm just going to save a bit of time and put them all in the calculator for you. Okay, so I popped them all in the calculator and these were the coordinates. These were the coordinates. Now I need to, once again, kind of determine their nature to find out if the concavity changes. So I need to prove that it's a point of inflection. So I whip up a table similar to the one before, but instead of doing f dash x, I do f double dash x at the bottom. All right, as you can see, like the one before, we've whipped up a table and you just want to choose numbers on either side of your points of inflection. So just choose the next obvious one. So say minus 4, minus 2, what's this one going to be? Minus 0.5 and then 1. And then for this bottom row, you just want to put these numbers into f double dash x. Okay, so I've just put all those numbers in the calculator and this is what I got. At the bottom of this table, you just want to draw what the concavity looks like. So if it's positive number, it's going to be a concave up. 0 will be nothing. Negative is concave down, nothing, concave up, nothing, and then also concave up. So as you can see, the only point of inflection is when the concavity changes. So when it goes from up to down. So this one is going to be a point of inflection. So minus 3, 0, minus 3. So this is a point of inflection. I'll just do that below here. And then you've also got minus 1 because it changes in concavity here. Okay, as you can see, down and then up. So this is also a point of inflection. And then 0, 0 is nothing. 0, 0 is just going to be a stationary point. All right, cool. So almost at the end. Now we're just trying to sketch this out. So on the right-hand side, I have got my points that I found. So I've got the min, the max, they're the stationary points. And 0, we figured out that was also a stationary point. We've got 2 points of inflection and we're trying to sketch it. We already know that there is one x and y intercept, but let's just see if there's another x-intercept that we can make use of. So x-intercept is when y equals 0. So 0 is equal to 2x plus 1 x to the 4. Now obviously that's going to be 0 because we worked that out here. But this, can that ever be 0? Well, no. So it can't ever be 0 because there's no number I can put in for x to make that whole thing 0. So the only x and y intercept is that, 0, 0. So let's whip up a graph. So I'm putting 0, 0 here. Now obviously this is not going to be to scale. So I've got minus 2 and 0.70. So somewhere positive here. So let's call that 0.7966. I know this is a max. Okay, and then what else do I know? I know that I've got a point of inflection at minus 3 and 0.54. So let's just say here, right? 0.545. And then I've also got another point of inflection at minus 1. So this is even lower than 0.545. So this is 0.367. So about here. Now what's going to help me to actually draw this is just to do a little turn where I know it's a min or a max. So I know 0, 0 here is a minimum, minus 2 is a maximum. Okay, so I also know my graph has to be here. It crosses this point here. That means it's not going to go, if this is a minimum and has to come back up here, it's not going to go below the x-axis no more because I found that it doesn't have any other x and y intercept. So I can reason that in between here, it goes like this, like that. And then on the left-hand side here, I've got a little point of inflection here. So it's going to come down like this, and it's just going to approach the x-axis. And on the right-hand side, because it's an exponential, well, as x gets super, super big, this whole equation is just going to blow up and get massive. So on the right-hand side, it's going to just basically go up like that. That was a tough one. I hope you found some value out of it. If you have any questions, let me know in the comments. And if you enjoyed this, please give me a like and subscribe. Otherwise, I'll see you in the next one. Peace.